So, all right. Uh, feels lonely. I know, right? Just us hanging out. Um, well, now there's 6 of us, so that's pretty good. I'm in here twice, so it doesn't really count. Uh, boosting my own numbers. Okay, so I'm not sure if you saw, but I posted a poll on Moodle to see, just to officially kind of gauge if you want to have a third test. I had a look at the schedule and it looks like the best thing would be December 3rd, so that's what I put in there. And that's the last day that we meet. So basically you'd go out with a bang and have a test on that day. I know you guys are pretty tested out, so and I think again that's the feeling that I'm getting from the responses that I have so far. But make sure that you do that poll because it's going to end. It's going to close at midnight tonight. So and then the majority decides, right? And so what we're going to do. Okay, so a little bit of background. I was marking your guys' test on Sunday. I'm using my iPad, blah, 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 blah. And then all of a sudden my pen stops working. And since then I have been trying to revive it. Doesn't work. So I'm on Jared's Surface. Luckily he has a Surface, but I am completely useless at using it. The assignments are due on Thursday at midnight, but the poll closes at midnight tonight. So I posted, so our note structure is going to be a little bit different. I apologize, just because you gotta improvise, right? So I posted a poll on Moodle to determine if we want to have another test. Okay. The poll closes at midnight tonight. Okay. And your vote, I just want you to know that it's anonymous, just so so you don't feel like that's holding you back. Your vote is anonymous, and the majority decides. Of course. Okay. And you should be able to see kind of where it's at after you've done your poll. But I'll post the results probably tomorrow. I'm not staying up till midnight your time. So, what else? Oh yeah, assignments. Assignments are due Thursday at midnight. Gotta make some more room for myself here. Okay, so we're getting into the home stretch here. So today we're gonna start trigonometry. We finished exponentials and logs last day, so make sure that you review those, and I'm gonna leave them out of the equation today, and we'll just start fresh on trigonometry. And we're gonna cut down a little bit on the trigonometry because I've talked to some other people teaching kind of similar courses and they don't go nearly as hard into trig, so I'm going to take that opportunity to not go nearly as hard into trig as well, especially because it's the end of the term and everyone's tired, and so we're just going to go nice and easy through this trig. So it depends on what the vote is. If there's a test on the 3rd, which is our last day, right? Next Thursday. Then it'll include all of the trigonometry, and we'll just kind of go until then. But otherwise, we'll use the 3rd for kind of a final exam review day where I just give you an idea of what to expect for the final exam. But all right. Any questions before we get started? So we got the assignments versus poll sorted out, so that's good. Okay. All right. So, like I said, I'm sorry about your tests not being marked. Like I said, I was working on them, and then all of a sudden, I think it's a software update on my iPad, and now all of a sudden my pen won't work, and it was supposed to go in and get fixed today, but then those people went into quarantine, and so now here we are. Anyways, I'm working on it. All right. Hey, what's going on here? Why did my keyboard come up? Okay, that's all right. Yeah, sometimes I lean on stuff on the surface and things pop up and it's confusing, but that's okay. I'm just not very good at it yet. All right, so today we will start trigonometry. Oh, oh, I am recording. Phew. Thought it was going to be the first day that I forgot. Hey, all right. I guess I forgot that I was recording. So today we'll start trigonometry. Okay, and so what's going to happen is we're going to work through, and there are essentially 2 approaches to dealing with trigonometry, and depending on what you're doing, you're going to want to draw from either approach. So we're going to start with the unit circle approach, and then we're going to go into the special triangles approach. Okay. There are 2 methods for solving trigonometry problems, or trig problems. Okay. The first one is the unit circle approach. And the second is the special triangles approach. Okay. So depending on what you're doing, right, one of these approaches might be better than the other. So depending on the problem, one of these approaches may be better than the other, better or easier than the other. I don't know how to change the, oops, maybe I do. Okay, that's maybe a little bit too thin. Okay, that's probably better. I don't know. So depending on the problem, one of these may be better or even easier than the other. And so that's just going to take some practice, right, to be able to recognize, oh, this is actually easier if I use the unit circle approach or if I use the special triangles approach. And so we'll start with the unit circle today. We'll start talking about it and kind of develop some of this methodology. And then we'll move into the special triangles, and then we'll kind of bring them together and look at them together. Okay. So 5.1, we'll call it, is just about introducing the unit circle. Oops. Oops. Circle-y. I keep wanting to do, I think I'm doing my signature. I think that's what's going on. There. Ugh. All right. So, first thing about the unit circle. Okay, so we haven't really talked about the equation of a circle yet. And this is kind of the first time that we see it. Probably, unless you remember from maybe high school. And so the unit circle is a circle with radius 1, right? Making it the unit circle, centered at the origin of the xy plane. So maybe I'll add that here. Centered at the origin of the xy plane. Oh, and I should kind of fill you in. Usually I have like a printout that I steal from. I couldn't figure out how to bring stuff in, so that's why we're gonna write it all out. So it's gonna go a little bit slower, but I think that's okay. We've got time. So the equation of the unit circle is x squared plus y squared equals 1. Okay, in general, x squared plus y squared equals r squared. So here, maybe I'll add that. R equals 1, right? Radius of 1. Just to get familiar with the unit circle, well, let's draw it out here. Oops. Like this, right? So here we are at the origin of the xy plane. And if we move out 1 unit, right? And so here we're at 1, here I'm at 1, here I'm at -1, and down here I'm at -1. Okay. So, okay, here we go. Let's see if I can draw a circle through each of these. Right. This is the unit circle. So on this circle, and I'm sorry, I don't have a pointer on here, so I'll have to describe it. But on this unit circle, right, we have xy coordinates all the way around, and they have this property that x squared plus y squared equals 1, right? So those are the xy coordinates moving along this circle. So we can talk about something like maybe here we've got a point xy. Okay. And so all the way around we've got this xy coordinate, and we can just call the point P, which is going to be kind of standard for when we're dealing with the unit circle, just talking about the point and calling it capital P. Okie dokie. So let's do a little example. Show that the point P of √3/3 and √6/3, oops, that's supposed to be a 3. I am digging that the The eraser is actually on the pencil. Oh, pretty handy. So show that it's is on the unit circle. Okay. So we have an XY coordinate. Right here we've got X and here we've got Y. We've got √3/3 and √6/3. In general, we're going to have these kind of weird numbers, but there is sort of a pattern that will start to develop. So √3/3, √6/3, pretty common things to see. So let's put them on in the equation here, x squared plus y squared, right? So if we have x and we have y, we need to make sure that it equals 1. We need to show that x squared plus y squared equals 1. Okay. So if we have x squared, and let me just write that out again here, x squared plus y squared equals 1. We know x is the √3/3. Then square all of that, right? Remember the square has to go on the outside. Plus √6/3 squared. And we're kind of seeing if it equals 1. Right, so I'll put a little question mark above because we don't know yet if it equals 1. So if we bring this square inside, right, it has to go on both things, right, in the fraction. And so we get the √3 squared, which is just going to be 3/3 squared, right? This brings us way back to exponent laws, right? When you have a fraction inside, you're allowed to bring that power inside, but it has to go on both the numerator and the denominator. Plus √6 squared over 3 squared. Does it equal 1? Okay. So now I've got 3/9 plus 6/9. Common denominator, great, right? So I've got 3 plus 6/9, which is equal to 1 because 3 plus 6 is 9/9. Therefore, P √3/3 √6/3, is on the unit circle. Woohoo. Okay. Just working more with the unit circle just to get kind of comfortable with it. The point P, which is at √3/2, and Y is on the unit circle. In quadrant 4. Okay. And so I'm gonna refresh your, hopefully you've got your quadrants from probably high school, but let's just review them. I'll finish writing out this example. I should have waited. I should have introduced the quadrants first, but anyways. In quadrant 4, find its y coordinate. Okay, so we have y here that we need to solve for. Okay. What I'll put, if we've got our xy plane here, right, xy, it's going to serve us well if we remember that, okay, this is quadrant 1, this is quadrant 2, 3, and 4. Okay. What happens here is, and I'll kind of use a different color. In quadrant 1, x is positive and y is positive, right? Positive, positive. In quadrant 2, right now we're on the negative x-axis, but still on the positive y-axis. So here we're at negative, positive. Okay. In quadrant 3, now my x's are still negative and my y's are negative as well. So I'm at negative, negative. In quadrant 4, okay, now my x's are positive and my y's are negative. So positive, negative. Okay. So here in quadrant 4, we know that our y value must be negative. So our y value must be negative. So that's the information that we get from knowing which quadrant it's in. Okay. So now, if it's on the unit circle, right, which it says, this point is on the unit circle in quadrant 4. So we know that this y value must be negative, and we have to find the y coordinate. Okay. So we know, again, x squared plus y squared is 1. Okay. And x squared is the root of 3 over 2 squared plus y squared equals 1. And we have to solve for y. Whenever there's a y squared involved, we actually get two values, right? We've seen it before. When we take the square root, we actually get the positive and the negative version of the answer, right? Because if you take, for example, if you have the negative root 2 squared, well, that's going to be 2. And then the positive root 2 squared is also 2, right? And so it doesn't matter if you put a negative or a positive back into the square, because it's just going to be the positive version. So when you take the square root, so when you move back to the square root, that's when you have to take the plus and the negative, or the positive and the negative of the whole thing. Okay, so solving for y squared, oh, keep moving this thing around, okay. Solving for y squared, we get y squared is 1 minus the root 3 over 2 squared. Now, whether you want to expand that out a little bit first before moving it over doesn't actually matter. So what we find is that y squared is 1 minus the root of 3 squared over 2 squared. 1 minus 3 over 4. Okay. I need to have a common denominator before I can combine these, and it's probably easiest if we combine them. So I'll use this. So times 4 over 4 to get that common denominator. So then I get y squared is 4 minus 3 over 4, which is just going to be 1 over 4. Whoops, y squared is 1 over 4. Okay. Okay, so when I take the square root of this, I get y must be the square root of 1 over 4. Okay. Just like with the exponents, when I bring them in, I can split this square root up, right? So I can, because I'm dividing inside, then I'm allowed to split the square root. So y is going to be the root of 1, which is just 1 over the root of 4, which is 2. But plus minus, haha. Here, I went on and on about how important it is to have the plus minus. And then I forgot to do it myself. There. Okay. So now we have the root of 1, which we said was 1. So y is going to be the plus minus of 1 over 2. Okay. But because earlier we said, wow, it's a lot of lofty work. Hey, that's the problem. I just realized there's no lines on here. That's why I'm writing so big. We said that our y value has to be negative, right? So it could have been positive 1/2, but because we're saying we're in quadrant 4, we have to take the negative version. Since y is in quadrant 4, we know y must be negative. So y is negative 1/2. Okay. Good. So that means that we've solved this problem, right? √3/2 and negative 1/2 is on the unit circle in quadrant 4. And so we found the y coordinate. Good. So let's see here. We need to talk about terminal points. And so there are a few things that we need to kind of establish in terms of the unit circle, but also getting into angles. So terminal points. Terminal points on the unit circle if we have some sort of unit circle like this, right, we know that we're going to go from, okay, here, this is our y-axis, this is our x-axis. If we go from, let's say here, and it's pretty typical that we do, we start at x is 1, y is 0, so 1, 0. Remember, we already established that these points are at 0, 1, at negative 1, 0, and at 0, negative 1, right? Moving through and just knowing these points on the unit circle. Okay. The terminal point is going to be the point that we land on, okay, if we move some sort of distance t. So here we've got a distance of t, and this is if t is greater than 0. So if t is greater than 0, so if it's positive, we move in the counterclockwise direction. So we start here on the x-axis, on the positive x-axis, and then we move to the terminal point. Okay, so t is the terminal point, and it's not really, it's the angle, but we'll leave it for now. So if t is greater than 0, we move in the counterclockwise direction. Okay. Whereas if we have something like this, and we move from here over here, right? Here we've got t less than 0. So if t is less than 0, making it negative, okay, we move in the clockwise direction. Okay. So here, oops, let me use a different, we're at pxy, and here we end up at pxy, depending on which direction we're going. So T is going to be an angle. Okay? But first we need to talk about, okay, so if we've got a positive angle, here, where can I add that on? If T is the angle. Okay. We haven't really introduced it, but it's good to know. Okay, so some things that we need to know are that, okay, the circumference of the circle, or of any circle, is 2 pi r, right? The circumference of any circle is 2 pi r. So the circumference of the unit circle with a radius of 1, right, must just be 2 pi. So the radius, or sorry, the circumference of the unit circle is 2 pi times 1, which is just 2 pi. Okay? So what that means is that if we move from our positive x-axis, if we move from here, and let's just go make a positive angle all the way around here, this would be a distance of 2 pi. We start, and I'll kind of highlight it here and bring it up again when we need it, but starting at, so 1, 0 is a typical starting point, okay? Is a typical starting point. On the positive x-axis. In fact, it's called the standard position, right? So if we start on the x-axis, on the positive x-axis, we're starting in standard position. Called standard position. Okay. So knowing that a whole loop around the unit circle gives us a distance of 2 pi, right? We can talk about some more cutoff points, right? So we see other cutoff points. Okay. Right, if I go from here and I go to here, right, I've moved a quarter of 2 pi. A quarter of 2 pi would just be pi over 2, right? And so these are going to be some definite kind of check-in points that we need to know. So this would be pi over 2. Here, if a whole distance around the circle is going to be 2 pi, then of course half the distance should just be pi, right? And so here, pi. Then I'll draw another one for the lower part. So here, going to there, we're at 2 pi over 3. I don't know why I said that. 3 pi over 2. 2 pi over 3 would put me 2/3 of a pi, so that would be less than this one. I don't know why I said that. Should be 3 pi over 2. Okay. So for these terminal points, right? I said that the t here is an angle. So what happens is that here, when we're talking about this 2 pi, really what we're saying is that t equals 2 pi. Yeah? Here, we're saying that pi over 2 equals t and pi equals t. Maybe I should have put those on separate graphs, doesn't matter. Right, so all of these are t, and so they have some terminal point, right? So we're going to use those points. Okay. All right. So if we think about, you know what, I will split this one up into 2. Let's see if I can kind of move this over. Okay. And all right, I'm doing it. Because what I'm going to do is I'm going to move this pi, this green one over. And I've got my xy. I should put xy on here, although it is implied. Okay. And then this one was going to be pi. Pi equals t. There. So if we think about these points, right, so we know on the unit circle, we already established where these endpoints are, way at the beginning, I guess. Here, right, we knew where, oh, sorry, I opened something here. Okay. I think I even did a better one. Nope, I didn't. All right, that's okay. We know what the x and y values are, so now we can just make these into coordinates. So this one, right, this ends when x is 0 and y is 1. This one ends when x is -1 and y is 0. This one ends when x is 0, oops, and y is -1. Okay. So let's see here. We can use these, right? And we can find the xy coordinates of any angle, or we'll start small and we'll just kind of use these, we'll call them reference angles. So, for example, find the terminal point, which would be something like this, okay, on the unit circle. Oops. On the unit circle, determined by each real number t. So A, we're going to let t be 3 pi, sorry. B is going to be t equals -pi. And C, t is going to be -pi over 2. Oops. Okay. So what we're going to do is, remembering that this distance is our t, So T is the distance traveled on the unit circle we want to find the point that that distance puts us at. We want to find the point we end up at. Okay. So let's have a look at A. Okay. So far, right, we've got our unit circle. We really only know 4 check-in points for now, right? Here, 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 and here. Okay. Eventually we'll develop a few more, but not too many more. We don't need to know too many more, but there are some go-to ones that we need to know. But the idea that we're developing here is going to stay the same. Okay, and so for 3 pi, okay, I know that if I go 2 pi, and remember, we'll just start here in this typical starting position. And so 2 pi is a full distance around. Okay, but then I need to go another pi, 2 pi plus 1 pi. And so another pi is going to put me here. Okay, this point, we know, right, x is -1, y is 0. So for A, the terminal point yeah, I'll say determined by 3 pi is -1, 0. Let's see if I can use the highlighter. Right? The negatives, remember the negative t's say that we have to move in the clockwise direction instead of the default counterclockwise. Right? And so here, move clockwise. Okay. So B, we had a t of -pi, so from our unit circle or on our unit circle, put that there. Okay, so I start here and then I'm moving, oops, I wanted a different color. Just to highlight things. Okay, so from here I want to move in this direction. Okay, and I have to move a distance of pi. So now we have to kind of check in, right? Okay, so pi in the negative direction is going to put me in the same place as pi in the positive direction, right? So let's see here. T equals -pi. Okay, puts me at a point of -1, 0. Notice that these end up at the same point. Okay, we're going to call that coterminal later on. Okay. So maybe I'll say, do I have a fun different color? Got these rainbow colors. Gotta love OneNote for that, right? So here, oops, keyboard keeps popping up. Oh, that's hard to read, but fun to see. But when when two angles have the same terminal point, we say they are coterminal. Okay, so we will see that again, but I just want to highlight that we're kind of seeing things as we go. Okay, right? Because it doesn't matter how you get there, right? We got to the same point, and so that's the point that we're talking about on the unit circle. Okay, so whether you go clockwise or counterclockwise, I guess I don't know. Is it a reflection? Anyways, doesn't matter. I think you know what I mean. So then the terminal point determined by negative pi is also negative 1, 0. Okay. So let's have a look at the third one. All right, so now I've got negative pi over 2. So pi over 2, if it was positive, would only put me at 0, 1, right? And so now I'm going to move the same distance, but in the negative direction, which is actually clockwise. So from here, I'm going to move to here. T equals negative pi over 2. Okay. So that point is going to be at 0, negative 1. Okay. And we'll say the terminal point. The terminal point determined by negative pi over 2 is 0, negative 1. So we have a pretty good handle on the 4 points, on these 4 points on the unit circle. So we have only used 4 points. Oops. 4 points on the unit circle so far. Right. X, Y, draw your unit circle, and here we're at 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Okay. So those are the only ones that we have looked at so far. Okay. It's going to be useful to know a couple more of those, right? Because here we said, okay, if my angle is, this one I wish I had a pointer. Maybe, is this it? Nope. Just wish I had a... Wish I had a pointer. Anyways, that's okay. Because we know if the angle is 2 pi, pi, 3 pi over 2, or pi over 2, right? We know where we end up on the circle. But those are pretty, pretty basic. Hey, what happened here? So what we need to do is we need to develop some more check-in points. Okay. These are the terminal points for t equals pi over 2, pi over 2, pi, 3 pi over 2, and 2 pi respectively. Okay. We're going to need a couple more terminal points, right? But what you're seeing here, if you look at 1, 0, for example, all that's happened over here is that now we have a negative x. So what you'll see is that we only need to develop some reference angles, is what they're called, in the first quadrant. Okay, and then keeping in mind how kind of your x's and y's behave. Where was that one that we drew? Here. Okay, so knowing how these things behave as we move through our unit circle, knowing the xy coordinates in the first quadrant, we can translate those throughout the rest of the quadrants, knowing if it should be positive or negative, or x values should be positive or negative. Where were we here? We need to develop some more reference points. Some more reference points. Okay. But we only need to develop them for the first quadrant, and then we can translate those into the other quadrants. But we only need, need to develop points in the first quadrant. And then we can translate them into the other 3 quadrants. And then we can translate them into the other 3 quadrants. Okay, so I'm just going to give them to you because I actually find, well, I don't know about you guys, but going through, and I have a math degree, but I actually find that trig is really, really difficult. It seems like there's some things, some secret things that I don't know to make it easy. So if that's how you're feeling, then you're not alone, right? But there are just things that it's going to make it easier if you just memorize it. And then once you have them memorized, then it's easier to go back and kind of convince yourself why that is. I looked at the proof of one of these. I didn't find it useful, so we're gonna skip it. And so that's why I'm just kind of giving it to you. Let's just memorize them. Because all our testing is open book, right? And life is open book. So not knowing these, you don't have to memorize them for real. You just need to know that you should have them available to you, right? So what we do, I'm going to focus on this first quadrant, and I'm going to make it nice and big here. Of course, I have to do it for the rest as well, but that doesn't look very good, does it? There. Okay. So here I am in quadrant 1, 2, 3, and 4. Okay. So in quadrant 1, we've got these check-in points developed, right? We're here at 0, right? So t equals 0 is at the point 1, 0. And here we said that t is pi over 2, which is at 0, 1. Okay. Maybe I should put little colons here to separate them. Okay. So now what we're going to do is we're going to just, there are 3 key check-in points between 0 and pi over 2. Okay. And so the first one is at halfway, which is at pi over 4. Okay, so that's halfway, and I'll write t equals pi over 4. Okay. Notice that this is halfway Okay. And so we can do some math to figure out where this point is, but this point is going to be at pi over 2, or sorry, pi over 2, root 2 over 2 and root 2 over 2. A little bit harder to get there than 0, 1, 1, 0, negative 1, 0, 0, negative 1, right? But that's why we have to memorize these. Okay, so pi over 4 is halfway, and it's going to be at root 2 over 2. It could also be, so here I'm going to make a note. We use x equals y equals root 2 over 2, which is actually the same as 1 over root 2, okay? But it's rationalized, okay? So, which is the same as 1 over root 2. If you think about, okay, so I want to rationalize the denominator, well, that means I have to multiply by root 2 over root 2, which we did. Okay. So rationalize the denominator. So this becomes root 2 over root 2 times root 2, which is just root 2 over 2, right? So notice all we've done is rationalize the denominator. Okay. In fact, I think, let me just flip back in our notes here. No, we did root 3 over 2. Never mind. Or did we? No. Yeah. Never mind. I thought the example we started with linked back to this. It doesn't. But it's very similar, right? So we're always on the unit circle. Here we're at this root 2 over 2, root 2 over 2. Okay, so if you have an angle of pi over 4, then your terminal point is going to be root 2 over 2 and root 2 over 2. Okay. The next kind of check-in point that we have is kind of part way to pi over 4 and then part way past pi over 4. So what those are going to look like. Like this. So here we've got t equals 0, which corresponds to the point 1, 0. Here, t equals pi over 2, which corresponds to 0, 1. And then the one we developed earlier, I'll just put it on here as well. T is pi over 4, which corresponds to root 2 over 2 and root 2 over 2. So the next one we're going to put on here and add to the mix is, let's do pi over 6. Let's see here. It's kind of here. T equals pi over 6. Okay. I'm just going to give it to you, right? And that's at the point root 3 over 2, which is the one that we worked through the example with before. So we know that in the first quadrant, right, the example we had, it was in quadrant, was it in 4? Can't remember. 3 or 4. Catch my here. Root 3 over 2 and 1 over 2 because y is positive in the first quadrant. Okay. The other check-in point that we have, and I'll just add it on here, is t equals pi over 3, which is at the point 1 over 2 and root 3 over 2. Okay. So we can summarize this as a table, right? If you want to, or if you prefer, it might be easier than drawing the circle. We can summarize these in a table. So we have t. We'll start at 0, then pi over 6, and so I'm just moving my way through here. Pi over 4, pi over 3, and pi over 2. Okay. And then the terminal point for each of these. Remember, this is just the same information that we have in the graph, so whichever one you prefer. Okay. Is at 1, 0, root 3 over 2 and 1/2. Pi over 4, we've got root 2 over 2, root 2 over 2. Pi over 3, we've got 1/2. And root 3 over 2. Notice the relationship here. Okay. Come back to that. And then pi over 2, we're at 0, 1. Okay. So what happens is we're going to use these and we're going to kind of replicate them as we go through through our unit circle, okay? Knowing where x is positive and where x is negative. So knowing where x is positive, or sorry, I should say x and y are positive and negative, where x, and y are positive / negative, we can use the terminal points from quadrant 1 in the rest of the quadrants, right? So which is what we're saying, but I'm just emphasizing. So we can use the terminal points from quadrant 1 in the other quadrants. Okay, so what this is going to look like, right, if we just remind ourselves, and all you really need to know is where x is positive and where y is positive and negative. So then here, this is quadrant 1, right, where we know both x and y are positive. Here we're in quadrant 2, x is negative, y is positive, right? You can just look at the axes, negative, positive, okay? Quadrant 3, I'm at negative, negative, and then 4, I'm at positive x and negative y. Okay. So as we move through these quadrants, right, we can kind of replicate these values here in the other quadrants. Okay? So here's what I mean. Let's try. Let's do it by example. Okay. So for example, find the terminal point determined by P or T. Determined by T. So A, T is negative pi over 4. Okay? Pi over 4 is one of these angles that we've talked about, right? Pi over 4 is the halfway point between 1, 0 and 0, 1, right? But now it's negative, so we're moving into quadrant 4, right? T is 3 pi over 4. And C, T is negative 5 pi over 6. Okay. So here, what we're going to notice, right, is, okay, it's negative. So just as a quick little note, I'm going to move this way, right? Negative pi over 4. Okay. Which puts me in quadrant 4. Where we just established x is positive and y is negative, right? So I'm going to use the positive and the negative of y. So the positive of x and the negative of y, right? So, oh, I don't know. Why did it do that? Okay. It's not showing you guys, so which is probably a good thing. You'd see all the things I'm hitting, but it's a little bit confusing. All right, so for A, what we're gonna do is we're just gonna draw the unit circle. So here we just kind of sketched it out, right, just to get a feel for it, but let's do it officially. So here, let's go draw our unit circle. Okay. So what we know is that at positive pi over 4, we're at the point root 2 over 2, root 2 over 2. Okay. So now, okay, so that's if we've moved in the positive direction. Now what I want to do is I want to do the same thing, but I'm moving in the negative direction, right? So here I'm at t equals negative pi over 4. Yeah. Okay. So now I've moved in the negative direction, but I've moved the same distance, right? And so what we do is this must be at the same x value, right? But the negative y value. Root 2 over 2 and negative root 2 over 2. Okay. Because the y value must be negative. The y value must be negative in the fourth quadrant. Okay. So that's what we mean by knowing those 3 quick check-in points, right? And where their points are on the unit circle. knowing those three, we can translate those to any quadrant that we want, right? So we can kind of mirror image them and figure out where we are in the quadrants, right? That can be difficult, to knowing which quadrant you're in to make it positive or negative, right? But once you have that under control, then you only need to memorize these. Okay, maybe what I'll say here is, well, memorize these, all groovy. Okay. Or if you prefer, you can memorize these, right? The table or the graph. I actually find the graph a little bit more of a crutch, right? The table, you kind of have to map them out yourself. Whereas if you're doing the circle, then you've kind of got them all already. Okay, so the terminal point for negative pi over 4, therefore, the terminal point for negative pi over 4 is root 2 over 2 negative root 2 over 2. Okay. Now, for B, we're looking at 3 pi over 4. So the first thing we need to do is we need to figure out where it is on our unit circle. Guess I'll start with the circle this time. Not sure why I did that. That's okay. Okay, so 3 pi over 4 is, okay, let's think about this. So 3 pi over 4 is 3/4 of a pi. So what we've done is 1/4, 2/4, 3/4, right? 3 pi over 4, 3/4 of a pi. Okay. So here we had pi over 4. Here we've got 2 pi over 4, which is pi over 2, right? But it is 2 pi over 4. And so here we're at 3 pi over 4, right? Knowing that it's kind of the halfway point, but on the other side, right? That means that it's going to have the same values as on the pi over 4 side, but now it's translated into quadrant 2, right? So here we are at quadrant 2. Okay. So what we get is, okay, over here in quadrant 1, we were at root 2 over 2, root 2 over 2. So now in quadrant 2, x is negative and y is positive. Okay. So the terminal point for 3 pi over 4, let me just make sure it was positive. Yeah. If it was negative, we'd have to go in the other direction. But because it's in the pi over 4 category, and that's what we'll soon see, is that if you're in the pi over 4 category, it's somewhere kind of bouncing around here, right? Halfway points. Let me remove too much. Oops. Recreate it. So the terminal point for 3 pi over 4 is root 2 over 2, root 2 over 2, but x must be negative. So I add a negative on the x, and y is positive, so I leave it positive since x is negative in the second quadrant. Okay. How about C? Oops. I can't quite remember what it was. Negative 5 pi over 6. Okay. So now we're looking at the pi over 6, but we've got negative 5 pi over 6. So negative puts me in the clockwise direction, right? And I'm moving 5 pi over 6, a distance of 5 pi over 6. So what happens is from here, if you think about, okay, 6 pi over 6 would put me at, okay, let's think about this. It would put me at pi, or 6 pi over 6 is just pi. So that would put me here, right? And if I want 5 pi over 6, then I'm just 1/6 shy of pi. So here, actually, maybe I'll keep that on here. 6 pi over 6. So this here must be 5 pi over 6. Sorry, negative 5 pi over 6. The halfway point, 6 pi over 6, it actually doesn't matter which direction you're moving. But we're interested in the negative 5 pi over 6. Okay. So what happens is, all right, okie dokie, I have moved from, now what color should I do here? No keyboard, thanks. Pi over 6 had a reference point, or sorry, a terminal point of root 3 over 2 and 1/2. Okay. So now what happens is I map that over. Well, I didn't do a very good job. Should go through the origin, but you can see my circle's all squished, so bear with me. Right? And so what happens is in quadrant 4, or sorry, this is quadrant 3. In quadrant 3, x is negative and y is negative. X and y are negative. Okay. So that means that the terminal point, therefore the terminal point, oops, for negative 5 pi over 6 is the negative root 3 over 2 and negative 1/2. Okay. Okay. So that's how we're going to find these terminal points. For me, if I was looking at this and this was my first time, it wouldn't be obvious that I could do something like this and just map it across, right? That's not necessarily obvious, but what I'm actually using is called a reference number. So I'll just define a reference number here. Oops, reference number. If we let t be a real number, that's just covering our bases so we don't have imaginary numbers. The square root of -1 is an imaginary number, which we don't talk about in this course, but let t be a real number. The reference number, now remember, t has been these points. T equals -5π/6, right? So they're the angles, essentially, right? Pi/4, 3π/4, right? So here we've had t equals each of these. So we're talking about the same t here. Let t be a real number. The reference number, which we call, or we're going to denote by t bar, okay, because it's related to t, but it's not actually t. It's the reference number for t. Associated with t is the shortest distance, I'll clean that up, along the unit circle between the terminal point determined by t and the x-axis, okay? So t is the shortest distance along the unit circle between the terminal point, which is what we were finding, right? Determined by t, and the x-axis. Okay. So what we can do is, from the previous example, we were looking at -5π/6. Okay, so here we said -5π/6 puts us at this point here. Okay, what I was really using was that, okay, well, that means that this distance here must be π/6, right? 5π/6 to get to 6π/6, I have a distance of π/6. So here, this is my reference number. So t is -5π/6, and then the reference number would be π/6, okay? Which is the distance from the x-axis, right? And it can be either the positive x or the negative x. Okay. So that's how I was able to kind of take from quadrant 1 and morph it into quadrant 3 and say, oh yeah, these map to each other because this distance here is π/6. So that's why I was able to use the π/6 points from quadrant 1. This is why we were able to use the terminal points of π/6 from quadrant 1. Oops. Okay. So there are a couple of tricky things, right? So reference numbers, there are a couple of ways that they can happen, okay? Reference numbers are always from the x-axis, or always from, I'll say, the nearest x-axis. from the nearest x-axis, right? Whether that's positive or negative. So there's going to be a couple of different scenarios here. We'll go through 4 scenarios. 1, I'll draw 2. Whoop, why did I do that? These unit circles are nothing to write home about. Why would you write home about unit circles anyways? There. Okay. In quadrant 1, right, let's say we move this distance. It doesn't actually matter what distance that is. Okay. Then here, t is its own reference number, right? In Q1, t is its own reference number. Okay. How about in the second quadrant? Okay. So now I'm moving to somewhere like this. Whee. Okay. Now, the closest x-axis here is actually going to be from here to here. Okay. So this point is my t-bar if this is my t. Okay. So the reference point is always from the closest x-axis. Okay. And the closest x-axis for all of quadrant 2 is on the negative x-axis. Okay. Oops. So in Q2, I should do Roman numerals. The reference number is always from the negative x-axis. The reference number is from the negative x-axis. Okay. Same thing with Q3. Okay. So what happens if we have this kind of run-of-the-mill something heading into Q3? Okay. Then this distance is my reference number. So here's my original angle t, and then my reference angle is only the distance below the negative x-axis. Okay. So what's nice is in Q2, you have to actually move back up to that point, right, to that terminal point. Whereas in Q3, you just need to subtract pi, right? So log off pi and just look at, okay, what's the distance here from the negative x-axis, right? And so in Q3, the reference number is, oops, is the distance past the negative x-axis, is the distance past the negative x-axis. Okay. Same thing if we move into the fourth quadrant here, anywhere. Right, so here's my t, it puts me in the fourth quadrant. Then my reference number here is actually going to be the negative, right? So moving from the positive x-axis but down. So here, this is my reference number. So in Q4, the reference number is the distance below the positive x-axis. Oh. So let's do some examples here. Oh, keyboard, go away. Find the reference number. Find the reference number for each value of t. Okay. So A, t is 5 pi over 6. B, t is 7 pi over 4. C, t is negative 2 pi over 3. And D, we're not going to do. No. I don't want to do that. I don't want to cloud your brains. It was just a decimal with no pi, but we don't need to know that yet. Okay. So 5 pi over 6, right? We can just draw a quick sketch here for A. I guess we'll do it down here. Come on. Draw our unit circle. 5 pi over 6, we've already seen it, right? But it puts us, so it's in the positive direction, which means it's counterclockwise. And we're just missing pi over 6 to get to the full halfway point here. Right? So here, t is 5 pi over 6. The distance, the remaining distance from the negative x-axis, the closest x-axis here, is going to be pi over 6. So therefore, the reference number is going to be pi over 6. Which we already used, right? We used the negative 5 pi over 6, but it behaves the same, right? So the distance here is pi over 6. For B, my unit circle, 7 pi over 4. Okay, let's think about what 7 pi over 4 is. I can pull out 1 pi over 4. I can't quite pull out 8 pi over 4, which would be 8 over 4 is 2 pi. So I'm not quite at 2 pi, right? But 7 pi over 4, I can rewrite, right? I can think about 7 pi over 4 as if it's, let's see here, 3 pi over 4 plus 4 pi over 4. Right? 4 pi over 4 is halfway. Right? And almost another halfway. Right? Almost another halfway. Should have written those in a different order. Right, so I can split up 7 pi over 4 to 3 pi over 4 plus 4 pi over 4 because I've kept that common denominator. Just to kind of see, and you can use your calculator too. Your fancy calculators will give you nice exact answers, and so that's really nice and useful. But so what happens is if we go halfway, right, that's 4 pi over 4, and now I have to go another 3 pi over 4. 2 pi over 4 would put me here, right? But I need 3 pi over 4. And so what I can do is move another pi over 4. Okay. So here I've got 4 pi over 4, and then plus 2 pi over 4, right? And then here I'm at pi over 4. But my reference angle then must also be pi over 4. So therefore my reference angle or reference number is pi over 4. It's the distance from the closest x-axis. We don't have to do the negative, even though I probably would have. But what we're using these from is, or for, is we use this from Quadrant One, and then we change to our positives and negatives depending on what quadrant we're in. We do not need to make this negative but knowing we are in Quadrant 4, we would make x positive and y negative, right? In our terminal point, I should add. In our terminal point. Okay. So the closest angle from the closest x-axis is pi over 4 if we're moving from, what was it, 7 pi over 4. Okay. What if we do the last one, negative 2 pi over 3? Negative 2 pi over 3, so now I'm moving in the negative direction. So okay, negative 2 pi over 3, I kind of have to use the same type of logic, right? So negative 3 pi over 3 would put me all the way over here, right? Negative 3 pi over 3, because that's just negative pi, right? So I'm not quite there, so I'm going to erase that. That was just to show, right? Hey. So negative 3 pi over 3, oh, negative 2 pi over 3. Okay, I have to move 2/3 of a pi counterclockwise. So what I can do is I can kind of split this up into thirds, right? Negative pi over 3, negative 2 pi over 3, and then here would be negative 3 pi over 3, right? I can split it into thirds. Okay. Which means that here, that's where I'm ending up at. Okay. Now, 2 pi over 3, the distance from 2 pi over 3 and 3 pi over 3 is just pi over 3. So this distance is going to be pi over 3 from the negative x-axis, right? Because I'm moving down because I'm in Quadrant 3. So many threes. Okay. Oh, and I guess I should. Therefore, the reference number is going to be pi over 3. So what we're going to use this for, right, is we can use these reference numbers to find points on the, to find terminal points, like we kind of foreshadowed here. Oh, lagging now a little bit. It's okay. Hey. So what I want to outline is just using reference numbers to find terminal points. Oh. To find terminal points. Okay. To find the terminal point P, to find the terminal point, and we'll just call it capital P, determined by any value T, determined by any value of T, we use the following steps. First, we find the reference number, right? So that's what we were practicing. So that's why we need to know that. So find the reference number. The only tricky part is sometimes if you're working in this section, right, you have to remember that you're moving from the negative x-axis. And so for me, that can be hard to remember sometimes. That's why I mention it. But otherwise, finding the reference number is not that bad. So find the reference number, oops, T bar. And you can just read it T bar, right? That's typically how we read something with a bar over it. The second step is to find the terminal point determined by by the reference number. So find the terminal point, and we're going to call it, oh, what happened? Okie dokie, artichoke. I lost you. Okay. I'm back. Yikes. Find the terminal point Q, and we're going to call it QAB, determined by the reference number. Determined by the reference number. T bar. Okay. The third step, the terminal point, okay, the terminal point, right? And so the reference number is always in Q1, always in the first quadrant. All right, so we'll always have, the terminal points will always be at a positive, right? So a positive x and a positive y. And then what we do is what we did earlier. So the terminal point determined by t is the point P at positive, negative, A, and B, depending on which quadrant you're in, where the signs are chosen according to the quadrant. Oops. According to the quadrant. Oops. The quadrant in which this terminal point lies. In which this terminal point lies. Yeah. So if you have something like, so for example, we talked about if t is 5 pi over 6, right? We already did this one up here, right? We said that the the reference number is pi over 6. Okay? So we can copy this first graph from A. So we found that this is what it looks like, right? First thing we did was we found our reference number, right? 5 pi over 6 with a reference number, which we already found, is pi over 6. Okay? So what that means is that we take from pi over 6, oops. Well, pi over 6, we know the point that pi over 6 is at. Pi over 6 is at root 3 over 2, 1/2. Okay. And now we take it into the second quadrant. In the second quadrant, this becomes x is negative, y is positive, negative root 3 over 2, 1/2. Negative, positive, right? So therefore, t equals 5 pi over 6 has a terminal point, oops, has a terminal point at negative root 3 over 2, 1/2. Okay? So we'll keep going with that next day, but I know I'm out of time. So spend some time memorizing those points that we talked about in the first quadrant, right? So definitely the 4 check-in points on the unit circle. I don't suspect that you'll have a lot of trouble with those, but definitely the pi over 6, pi over 4, pi over 3, and what those points are. And you're going to find that all of this trig is going to be so much easier if you have those kind of committed to memory, or maybe on a sticky note somewhere as you work through these problems. Okay. Any questions before I let you go? Stop this.